Hey guys, Assalamu alaikum. Today we are with the lecture of chemical bonding. Till now we have finished few of the concepts. It was kinetic particle theory at the first, and then application of kinetic particle theory, that was a diffusion. Further details related to interconversion of one state of a matter into another state of a matter. What are the heating processes, cooling processes, their graphs, etc. Afterwards, we move to the topic of apparatus, gas collection, what are the measurements which we can make in the lab. Further, we move to the topic of purification techniques, separation techniques, and then the chromatography, which is called paper chromatography, a very, very important topic regarding paper point of view. Then we move to the basic introduction to the element, compound, mixture, differences between them, different stuff between monoatomic, polyatomic elements, etc. The details related to electronic configuration, how to calculate the neutron number from the given symbol of an element, what a symbol of an element telling you. And then the last topic in the last two lectures was a very, very important topic, and that was isotopes. Now we are moving to the next topic, which is called chemical bonding. Guys, before starting this topic, I would like to inform all of you that this is very, very important regarding paper point of view. Examiner can ask the questions related to chemical bonding, not only in the MCQ, rather in the theory paper as well. He can ask you certain reasons for the high melting point of a substance, for the low boiling point of a substance, for the high forces of attractions among the particles. And so all the explanations are based upon chemical bonding. Examiner may ask you to draw the structure of a substance, of a compound regarding chemical bonding. We are going to unlock all these mysteries in this chapter. Yes, what is chemical bonding? First of all, elements of periodic table want to achieve the electronic configuration matching with that of the elements of group number 8. Why? What is the problem with the elements? Why they want to copy them? What is the reason behind that? Basically, we have studied from the topic of electronic configuration that the electronic configuration of elements of group number 8 is stabilized. We have assigned the stars to the elements of group number 8. And why it is so? As they have complete electronic configuration or they have stabilized electronic configuration. That's why elements of the periodic table want to attain that electronic configuration. All right. Now we are moving towards next page, and that is telling us that how elements are achieving different types of the electronic configuration. What is happening with different elements to achieve the electronic configuration of the elements of group number 8. Okay. So right now, before moving ahead, I would like to tell you that there are three types of bonding. Number one is ionic bonding, which is also called electrovalent bonding. Then, number two, covalent bonding. These are the bondings of your syllabus. And the next is metallic bonding. Now we have written three types of the bonding here. So only these three types of the bonding are part of your syllabus. When you people will be shifted to AS level, over there we are going to teach you two more types of the bonding. One type of the bonding which we will teach you in detail in AS, that will be the coordinate covalent bonding, or that will be also called as the dative bonding. And there will be other type of bondings as well, which are called as intermolecular forces of attractions. So remember this thing that I am telling you: dative bonding. Dative starts with D for dolphin. Dative bonding, and the other name for dative bonding is coordinate covalent bonding. Along with the intermolecular forces discussion will be carried out with you people in a S level. Okay, so right now I am going to discuss all these three with you one by one. Okay, before moving ahead, I would like to explain you the target of all these three types of the bonding is to achieve the electronic configuration of elements of group number 8. Okay, this is the target. Done. Okay. Now, before shifting towards ionic bonding, this is an important topic. This is an important point to be discussed, that either elements of periodic table are doing bonding and they are all convert themselves into the elements of group number 8. No, 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 basically they are doing ionic bonding or covalent bonding or metallic bonding to match their electronic configuration with elements of group number 8. They themselves are not converting into those elements. For example, if an element, for example sodium, is giving one type of a bonding, and after doing that bonding, its new electronic configuration is matching with neon. So now sodium is neon? No, sodium's new electronic configuration is matching with neon. Okay, this is a very important concept which I was thinking to tell you. Now I am shifting to the topic of ionic bonding first of all. All right, so we can say this thing, that in ionic bonding, what is happening? Okay, so in ionic bonding, basically metal and non-metal are involved. Okay, metal either group 1, group 2, group 3, group 4 and 5 have also metals at the bottom. Okay, and we can talk about this: non-metals, group 6, group 7, group 4, group 5. Basically, we should say this thing very clearly, that elements of group number 4 are not involved in bonding of ionic. Okay, and why it is so, I'm going to explain. And why this is on both sides, this is a point to be discussed as well. Okay, right now, elements of metals side are losing electrons according to their group number. Okay, whereas elements from the non-metallic side are gaining electron according to what? According to their group number. Done. Okay, now I'm changing the board to tell you the details related to this. So basically, before moving ahead, I would like to inform you that to lose electron and to gain electron is involving lots of energy exchange as well. This is not a pencil that I am giving a pencil to someone or I am taking one pencil from someone, so it is as easy. No, we have to provide a specific amount of energy to an atom of an element so that it may lose electrons or so that it may gain electrons. So loss of electron or gain of electron, both are involving a specific amount of energy. Remember this thing, that electrons are revolving around the nucleus in the specific electronic shells. This is our knowledge from the topic of atomic structure. Now, what is happening, that nucleus is containing protons, which are positively charged particles. They are holding the electrons very tightly. So, as a result, electrons are revolving in the specific electronic shells around the nucleus. But it is difficult to remove the electrons from the influence of the protons, and similarly it is also not very easy to add one electron in the previously present electronic shell. Why? Because electron is a negatively charged particles, and the previously present electrons in the same electronic shell are also negatively charged particles. So it is very difficult to overcome that repulsion created by those electrons, and it is also very difficult to overcome that attraction which is created by the protons to keep the electrons around it, okay, around the nucleus. So it is the energy which is required to overcome either the forces of attractions or the energy required to overcome the forces of repulsion created by the electrons, okay. So that's why, due to these forces of attractions and forces of repulsion, it is not easy to add the electron, it is not easy to remove the electron. Both of the processes are involving specific amount of heat energy, okay. So let me inform you very clearly that all in ionic bonding very clearly. In ionic bonding, okay, group number 1 elements are losing one electron from outermost shell. Outermost shell is also called as valence shell, okay, valence shell. Okay. So remember this thing. There is one more point, that these are always the electrons of the outermost shell, the valence shell, which are involved in all types of bonding. Rest of the electrons which are more closer towards nucleus are never part of any type of bonding. Okay. So more you are going towards the nucleus, more it is getting difficult to engage them in any type of bonding. So this is the reason, that's why electrons of the outermost shell are involved in all types of bonding, okay. So this is group number 1, losing one electron from outermost shell, that is called valence shell. And all the elements of group number 2 are losing how many electrons? 2 electrons from their outermost shell. Group number 3 is losing 3 electrons from their outermost shell, whereas we are currently we are not talking about group number 5, but I will discuss group number 5 as well. If we are talking about group number 6, we can say that it is gaining. Now I have marked a line clearly. Group number 6 is gaining 2 electrons from in its outermost shell, whereas group number 7 is gaining how many electrons? It is gaining 1 electron in its outermost shell. So loss and gain of electrons in every group is related to the group number. One should know this thing, that all the elements of group number 1 have 1 electron in its outermost shell. Definitely they are going to lose that 1 electron from their outermost shell. And all the elements of group number 2 have how many electrons? 2 electrons in their outermost shell. So they are going to lose 2 electrons. Yes, there is a relationship between the number of electrons in the outermost shell and the group number, that I am going to tell you in the next class, inshallah. Take care of yourself. Thank you very much.